Hello friends, I hope you like my videos, and if you are having any question you can ask me in the comment. So friends, in this video we will discuss about the one of the frequently used investigation tools, that is fishbone diagram, right? Friends, my YouTube channel name is Pharma Quality, so please view, like, comment and subscribe my channel to get the knowledge about the pharma quality standards and practices. So now in this slide we will discuss what is fishbone diagram. So fishbone diagram, also known as Ishikawa diagram or cause and effect diagram, right? It is a valuable tools for investigating and organizing the potential cause of a specific problem. It basically helps teams to identify the root cause of problems by visually displaying various contributing factors, right? So by using these tools you can perform a detailed investigation and find out the root cause. Now we will discuss when fishbone diagram is used, right? So the fishbone diagram are a part of root cause analysis techniques which are used by pharmaceutical firms to analyze the deviation and avoid series of near misses, right? So basically during any non-conformance, deviation out of specification or out of calibration results, fishbone diagram tools we can use to identify the root cause, right? So which is one of the most effective tools to identify the root cause. So here now we will discuss the key components of a fishbone diagram. So first one is head of fish. So here you can you need to write the main problem or effect that is being analyzed. So you can see the head of the fish. So here you need to elaborate your problem, right? Second one is the spine. So horizontal line, this one, which represent the timeline or progression of this issue, the problem statement, right? Next is bones, this one. So mainly these bones are having the man, machine, a measurement method, mother nature and material, right? Next is branches. So here you can see in the bones there are several branches we can elaborate, right? So a specific cause within the each category we need to elaborate. So details of this we will discuss in the subsequent slide, right? Now here we will discuss how to use fishbone diagram, right? So first one is the problem statement. As we discussed, we need to write down the clear and specific problem. So we need to define the problem at mouth of the fish, right? Next is the category of potential causes. So we need to write down the potential causes as man, machine, material, method, measurement and mother nature. So we need to define these at 6 different bones, right? Next is specific causes. So we need to write down the specific cause for each potential cause in man, machine, material, methods, measurement and mother nature. So we need to define the specific causes at branches, right? So now in this slide we will discuss the application of fishbone diagram investigation with an example. So let's take an example that out of calibration results observed in wavelength accuracy test, right? So man, method, machine, material, mother nature and measurement will be your potential cause, and the specific cause will be like this one, all the branches we have mentioned, right? So let's start with the man. So in the man, you can associate with the training and qualification. So first, training. So here you can investigate, like you need to check that analyst is trained on the particular SOP and instrument or not, right? So such thing you can evaluate it. Next is qualification. So in this we need to check the qualification status of analyst in that particular test and instrument also, right? That analyst is qualified to execute that test and handle that instrument, right? Next is machine, right? So here the first one is the preventive maintenance status. So here we need to check the preventive maintenance status of instrument, that is preventive maintenance status is completed or not, right? So next is instrument error. So in this instrument related, you can check the instrument physically, right? So check for proper dipping of port in the mobile phase, or check each module for any kind of leakage, observed leakage is there or not, right? Next is column. So in this you can check the correct column is used or not as per the SOP. So you can verify the dimension of the column and other details as per the respective calibration SOP, right? Next is sequence. So related to sequence, you can check for any error related to method selection, vial position, injection volume, etc. And apart from this, you can also check the pressure channel to identify any pressure drop, and you can check the chromatogram for each injection to check the peak shape and RT variation if there is any, right? So in this way you can investigate. Next we will discuss the method. So instrument setup procedure. So here in this you can check the analyst setup the instrument as per the internal procedure or not, or may there will be the checklist to set up the instrument prior to start the sequence. So you need to check that instrument is set up as per the required procedure, right? Next is SOP verification. So here you can check the calibration activities performed as per the correct SOP or not. Next is calibration method. So here you can check the calibration parameter as per the SOP or not, right? Next is material. So we'll discuss investigation details with respect to the material. So first one, glassware use. So here you can check the glassware, that is all the pipettes or volumetric flasks that are used as per the respective procedure or not, right? Next is chemical used. So here you can check the all chemicals or solvents used in the preparation that is correctly used as per the SOP and it is within the validity or not, right? Next is standard use. So here you can check the standard used is correct as per the SOP or not, and it is within the validity or not, right? So in this way you can investigate. Next is mother nature. So here the laboratory area. So in this you can check the you perform the calibration activity as per the control condition or not, that is temperature and relative humidity of that area are okay or not, right? So in this way you can investigate. So next is measurement. So here the calculation of results. So here you can verify the final results observed is correctly calculated or not. So there should not be any calculation related error, right? So in this way you can make a fishbone diagram and investigate your non-conformance. So what I have explained just based on the one example. So it may vary based on the problem statement or different nature of conditions, situations, right? So this is for the training purpose only, right? So friends, this is all about the fishbone diagram investigation tools, right? So thank you so much for watching the video.